Working with LiDAR in ArcGIS Pro. Once again, here's our itinerary for the day, broken down to just a couple of steps. We have just completed our welcome and introductions, or almost completed it. You'll see that we have a little bit more coming up where you get to be involved. We'll have some presentations and discussions, hands-on exercises, question and answer sessions, and wrap up before the end of the day. Don't think that your questions need to wait for a point where I ask, are there any questions? If you have a question at any time, just ask, interject yourself, unmute yourself, and feel free to ask that question. My name is Keith Weber. I'm your facilitator, your instructor, your teacher for the day, whatever term you like to use. I'd like to acknowledge the Idaho LIDAR Consortium. I've been working with those folks, Nancy Glenn and Josh Enterkine over there in Boise. Been working with them for years. We here at the GIS Center have invested in some fairly substantial infrastructure in the way of very, very large servers. The university here has invested in Globus as a subscription to as easily as possible provide these big data to you, to anyone who wants to access LIDAR for Idaho. So we are kind of the back end of the ILC, Idaho LIDAR Consortium. Work very closely with these folks. And in fact, just yesterday, a couple of days ago, we received a new delivery of LIDAR data for the state of Idaho. It's the Teton County acquisition, the Teton County project. And so I was communicating with Nancy and Josh about that timeline to get that data posted up on the ILC and have it ready for you all to get access to it. Also like to acknowledge FEMA. FEMA and the CTP program are providing some funding to the GIS Center here at Idaho State University. And part of that funding covers this workshop and the fact that I'm teaching this workshop, which is why this workshop does not bear any cost to you, no registration fees. So that is thanks to FEMA and the CTP program. We also would like to acknowledge the Idaho Elevation Technical Working Group. I'm a member of it. Nancy Glenn is the chair of it over there in Boise State University, and of course the USGS 3DEP program. Between FEMA, USGS, and a couple of other federal agencies, but those two, that there's a lot of funding that they have provided to allow us to acquire LIDAR imagery in the state of Idaho. And so a good acknowledgement and thanks out to those folks at both FEMA and USGS. Part one of the presentation here today is, what is LIDAR really? What is it really? Okay, so LIDAR data, first of all, you probably noticed this just with the exercise file. LIDAR data is big data. LIDAR is an acronym. It stands for Light Detection and Ranging. It's spelled all different ways. The more common LIDAR becomes, I see most people are not spelling it in any special way. You know, originally it was L, capital L, lowercase I, then because the rest of it's an acronym, everyone would put it into all uppercase. Now it's just becoming a word, and people are just writing LIDAR. So whatever, I will actually probably use it in both ways today, both in the exercise that I wrote for you, as well as in these slides. So in this workshop, by the way, we are going to focus on airborne LIDAR, not terrestrial LIDAR or TLS. We're not going to really talk about that or deal with it at all. So what is airborne LIDAR then? Well, it's a way, relatively new, to collect elevation data. And in effect, an aircraft passes overhead, and an airborne, an onboard sensor emits a laser pulse. So it's therefore an active sensor, in contrast to a passive sensor like the Landsat satellite, Sentinel satellites, and so on and so forth. They simply record the light that is reflected off of the Earth's surface. An active sensor, like LiDAR, sends out the energy source, laser in this case, and then receives laser returns. It listens for a return on the signal that it just sent out. So for every laser pulse, each laser pulse we can think of as a single point, really no different from any other point in GIS, okay? A point on the ground, wherever that laser pulse struck. The attributes of each point include a minimum of X, Y, and Z, as well as T, time. And as far as that aircraft is concerned, the roll, pitch, and yaw of the aircraft, so that that data can be processed and the returns for a given pulse are assigned to the correct pulse. Okay, and you see how that plays a very important role here in as we go through this. So for each return then represents another point. So for each return represents another point, just like the pulse itself. And it is attributed with a minimum of an X, Y, and Z, right? X and Y and Z, Cartesian coordinates effectively, T, as well as the intensity of that recorded return. So each return is a record in an LAS file, and that file occupies 20 bytes in size. Okay, so a record or a row in a database table, think of it like that. That's effectively what it is. And that information that's stored in the LAS file, you can see right there, this is following the ASPRS LAS format version 12, which as far as I can tell is still the newest version that's out there. And there's our X, Y, and Z and intensity, the return number of returns for the given pulse, so on and so forth. Lots of information. Okay, lots of information is not just the X and Y or an X and Y and Z. Now, high quality, we'll call it high quality LiDAR data, QL1, will have numerous returns per pulse. Okay, and this QL1, QL2, even there's now a QL0, that lets us know how many returns in general, how many returns there are per pulse. And to achieve QL1, you have to have at least 8 returns per pulse. If you don't achieve that, then you're automatically in QL2. If you don't achieve that standard, then it drops to QL3 and so on and so forth. So let's say there are 8 pulses per square meter, exactly 8 pulses per square meter. A lot of QL1 stuff, by the way, will have more than that. In fact, oftentimes I'm seeing QL1 stuff will actually have about 12 pulses per square meter. The reason why the vendors do that is because, number one, they're contracted to deliver QL1 data. And they need to make sure that they are delivering at least 8 pulses per square meter. If they fall below that number frequently enough, that'll be a problem because they're not really delivering QL1, they're delivering QL2. So a lot of vendors are upping it just to make sure that they are really providing and delivering QL1, so they'll up it to something like 12 pulses per square meter. So as that aircraft is flying over us, whatever, flying over the landscape, it is firing out 12 laser pulses or 8 laser pulses for every square meter on the ground. So a 100 square kilometer area, that's just 25,000 acres. That is 100 million square meters. We can write it that way. That is 800 million pulses for QL1 data. 800 million pulses, 800 million points. How many folks have used a data set, a point feature class that large ever? I don't think I ever have. That's gigantic, other than LiDAR. 800 million points in total. And ideally, it will be at least 800 million returns. That's if it only has one return per pulse, but that actually is extremely rare, where we have only one return per pulse. And if we only have 800 million returns in that LAS file, or 800 million points, that already is 16 gigabytes of data, just for that relatively small LiDAR project of 25,000 acres. A project tile is a way that those project areas, the large project areas, are chopped down or made smaller for management, data management, and all these sorts of concerns and considerations. So perhaps this 100 square kilometer area is only one tile in your project. For example, Bannock County, Idaho, where I am standing right now, covers nearly 3,000 square kilometers. So Bannock County then would require 30 of those 100 square kilometer tiles. That then is 480 gigabytes of raw data. 480 gigabytes of raw data. In other words, just about half of a terabyte. But the project isn't over with yet. The project can easily grow to over 1 terabyte in size, because all that I've talked about so far is an LAS file with a single return. Okay, just a single return. Then, of course, we would oftentimes have vector tile polygons, some shapefile or geodatabase showing us the extent and the perimeter of those tiles for our management, so we can access things as we need them. Vector break lines or lines and polygon data. Again, we need to have the metadata. We need report documentation, normally in a PDF format, plus the derived raster products such as elevation or the surface, the highest hit, and the intensity layers. Those are all very common deliverables, what you're seeing there up on the screen, kind of a common package. The big one, of course, is the LAS files themselves. This normally constitutes 60, 70, 75% of the entire project's size. The rasters can be pretty big as well. Okay, the rasters make up the next largest proportion of that pie, and then the metadata and report is really pretty small part of that overall picture of the project itself. But if you, to put it in one slide there, LiDAR data is big data, no doubt about it. We see the LiDAR looks like some great stuff. Boy, we want to use that LiDAR data, but now we're learning what's beneath the surface, right? All that LAS files and downloading and acquiring that sort of stuff. So this makes LiDAR different. The fact that it's so big, the sheer size of LiDAR data can stress computer hardware, computer software, your hard drive, your network. Everything takes time, or more time than we're probably accustomed to. The download, we're so accustomed to a download completing in about a minute, couple minutes maybe. Well, based on your network connection, this stuff can take hours to complete. The network connection that we have here at the university, my servers are not even in this room or this complex, this building that I'm in right now. They're in ISU's RDC, Research Data Center. And it has a 40 gig per second backbone out to 100 gig per second high-speed network and all that. So that's really cool. There's nothing really restricting our access that way. And when I go on to Globus, I use that Globus service. And when I use that to download this same data set that we're using today, that exercise data, it took me 2 minutes to complete that download, 10 gigs, 10 plus gigs, whatever. But some of you have reported to me that it took you a couple hours to get it done. One person, the last time I taught it, couldn't at all use Globus, so I had to move it to another server, which I don't think was as fast as our big LiDAR server, and then give them access to it. It took them 4 hours to get the data. It takes a while. And then once we have it downloaded, of course, we need to extract it. The extract process isn't too long, but then we need to do something with it, right? Process that data. We're going to do that today. We've already downloaded it, so we're going to extract it here in just a little bit, if you haven't already. Then we're going to process it, and then we're going to work with the data, okay? We're going to ask it some questions, do a little bit of spatial analysis to show you some of the capabilities of LiDAR data. But it's more than just big, right? Yes, at its heart, LiDAR is elevation data, right? So a lot of us are very accustomed to using the older USGS DEMs, right? Digital elevation models. And when I first got into GIS, a good DEM was 90 meters by 90 meter pixels. And then very quickly after that, I started getting access to 30 meter by 30 meter DEM data. And then along came the space shuttle, the shuttle radar topography mission, SRTM, and then from that came NED, the National Elevation Data Set. Pretty darn good stuff, 10 meters by 10 meters across the nation, seamless. Very valuable data set even still today, because LiDAR does not have edge-to-edge seamless coverage for the entire United States. That's of course a goal, and I wouldn't doubt that some years from now we will all be poo-pooing NED and previous older DEMs, because we will have achieved, as a nation, we will have achieved 100% coverage of LiDAR across the lower 48 at least. I think that's going to happen, in X number of years. It's not real soon, but it'll definitely happen. But you see, there's more to it than just that surface elevation, like a DEM and so on. There's also our highest hit, top of canopy type of data. And sometimes we'll also get second returns and third returns. So we can start understanding, or you can start understanding, the understory of a forest, the different canopy levels in a forest. You might find, you might learn through LiDAR that this area of a certain forest that you may be managing or helping to manage has a nice tall canopy, mature trees, but you're not seeing any second or third or understory returns. And if you go out and do a little bit of field validation, you'll see, hey, this LiDAR is correct. There is very little understory here. There's no ladder fuels in this part of the forest, but you go to another part of the forest where you were picking up second and third returns after that highest hit, and you get out there and you might say, I see a lot of understory here. I'm seeing ladder fuels all over the place in this part of this forest. And of course, wildfires are a major concern across the West, especially. And for those of you who don't know me too well, one of the things that I've worked on a lot over the years is land cover change. That's really my emphasis research program. And of course, worked really tremendously on wildfires. A lot of studies funded by NASA, working closely with the Forest Service, very closely with the BLM, Idaho Department of Lands, National Park Service on various wildfire projects over the years. So a lot of my examples will be related to wildfires. Another great application of LiDAR is in post-wildfire assessments. So one huge concern in a post-wildfire scenario for lots of the Western United States is the debris flows, post-wildfire debris flows. And these can happen sometimes a year or more after the wildfire actually happens. And so to model or forecast the likelihood of a future debris flow once a fire has burned, one piece of very important data is, of course, the topographic data. And the USGS has a very good landslide hazards program, and part of that program calculates the likelihood of a post-wildfire debris flow. Folks over there do a really neat job, good job of getting that data out as quickly as they can following a wildfire. And of course, they're going to use the best available data, and oftentimes that is that 10-meter NED data. But as LiDAR becomes more and more available, we're going to see those models being made with LiDAR data, and as a result, there will be an improved confidence in the result of those models on likelihood of a post-wildfire debris flow. There is also lots of jargon associated just with LiDAR. Some important products, jargon about those products that you need to know, and we're going to be referring to today is, we'll just start here on this list, BE. The letter is BE, that's bare earth. That is effectively our DEMs, very similar to our DEMs, okay? And that is also our last return from these laser pulses. The highest hit, top of canopy, top of building, that's our first return. We'll have some intensity images, okay? Those are separated out just using the intensity data or field from the LAS data. But then we can take those BE layers, bare earth layers, and work with them a little bit more, improve them, value add them, let's say, and to then create either a HF, hydro flattened layer, or an HE, hydro enforced layer. Hydro what? Wow, okay, so hydro flattening effectively creates an elevation layer that is identical to a DEM and compliant with the USGS specs and the specs according to the National Elevation Data Set. So hydro flattening is where the BE layer has integrated the break lines, break line data, and once that is done and you produce a raster, let's say, a raster output from that, then you actually have created a hydro flattened layer, surface layer, okay? And we can see the difference by looking at the slide or the image on the left and comparing it to the image on the right. This is essentially just a BE, or bare earth layer, and here is a hydro-flattened layer. Notice that the river that we're looking at is flat across that river. Whereas in this case, because we were just using the BE points, the last return points, let's say, we had some anomalous information inside the river channel itself. I don't believe that that river really looked like that, underneath the water. And that's a pretty good assumption that it probably really doesn't look like this. So the hydro-flattening process cleans that up and makes it all the better. This is very apparent in this main river channel, and also, although a little bit less apparent, in this lake or pond just off of the main river. So that hydro-flattening has been applied using break line data. That's hydro-flattening. Then we move up to hydro-enforced data. It's a further modification of a hydro-flattened surface layer. It's useful for engineers, hydrologists, as water flow can be more accurately modeled to act as it really does in the real world. And a good example of hydro-enforced layers is when culverts have been integrated into our model. So on the left side here, we're looking at a hydro-flattened layer. It looks nice, okay, it looks good. We see that the bridges, there are no bridges, those have been removed, so that's good. That way the flow, direction flow accumulation models can actually flow the water, even in an HF, underneath this. That's fine. But what it doesn't include are things like actual culverts, one here, and one here. So all that water that's coming off this slope right here, in this model, it would just pond up right here. More water, it would pond up until eventually the flow accumulation model would start spilling it over this road. But that's not what really happens. So the culvert allows that water to flow through under the road effectively, and then follow this channel in, and so on and so forth. Now, there's not like some really crazy wild way of doing that. What that thing is doing is it's just removing or adjusting the elevation of those pixels right here, dropping them down so that it meets the elevation below or the same elevation that the culvert exists at. So to do this, you'd have to have the X, Y, and the Z location correctly collected for the inlet, where's my mouse? For the inlet of each culvert and for the outlet of each culvert. Once that's in there, you can pretty darn easily modify that raster layer and slice out the topography, the pixels, to make a hydro-enforced. Now, wouldn't be too hard on that chunk of imagery we're looking at right here. There's only 3 culverts, 3 culverts with 6 points, right? Inputs, inlets, and outlets. In a large study area or a large project area, you might have hundreds and hundreds of culverts to deal with. So then it becomes this other lengthy process, very lengthy and time-consuming process. Break lines, I've thrown that out a few times already. Break lines are, and I'll go ahead and take some time to define these, they are vector lines, arcs, and also, as you're going to see today, we'll work with some polygon break lines that define actual abrupt changes in the topography or elevation. These line features include a known elevation. We know that at the edge of this roadbed, okay, this is the elevation. If I go down here a little bit, it's an elevated roadbed, then this line right over here represents a different elevation. Maybe I have a different break line right there. And examples, of course, include those road grades, cliffs, shorelines, the edge of rivers, and so on and so forth. And of course, there the break lines are used for the hydro flattening layer that we're going to produce. We'll actually do that today. We will use break lines for our project area, and you will produce a hydro flattened layer before we get done today. So I am on to questions. If you have any questions, I see a couple things have come in to the chat. I will take a look at that. A brief intro to ArcGIS Pro. I'm going to assume that a lot of you have already, or you have some experience in GIS. I'm sure it varies quite a bit across the board with a workshop. When we have this many people in it, we have about 20 people in here today, so it's going to vary. Some people, I'm sure, are pretty new at GIS, while others have been at this for a while. Well, what is ArcGIS Pro? It is really one part of ArcGIS Desktop. And starting with, and now a couple of years ago, version 10.4, Desktop contains Arc Catalog, Arc Map, and ArcGIS Pro. Arc Catalog and Arc Map are at levels or version 10.8, 10.8.1, I think is the most current. And the most current ArcGIS Pro is actually 2.7.1. A new patch just came out the other day while I was teaching workshops. I didn't bother installing it yet on this machine. I did install it on my research workstation. It doesn't look like it's much different at all from 10.7. I'm sorry, 2.7. Normally that .1 simply means that they've got a couple of bugs that they detected, fixed and worked out. So for this workshop, as long as you are on, ideally, at least 2.6, ArcGIS Pro, it's going to work out just fine. You might see some slight nuances, slight differences. A button might say run on your machine. The exercise might say click OK or apply or something like that. It's going to do the same thing, just slight difference in the terminology used here and there in ArcGIS Pro. And of course, once you go to the hands-on exercise, if you have any question, just let me know. And what we've been doing, what I do on previous workshops or in my virtual classes, I'll ask you to do a screen share on your side, and then it's more or less like I am at your shoulder and able to help you out with whatever problem you might be encountering. Now, ArcGIS Pro is standalone software. You do not need to have Arc Catalog and Arc Map already installed. You can, it can be there, it won't cause any problem, but it doesn't do you any good either if what you're going to do is use ArcGIS Pro. ArcGIS Pro is 64-bit, 100% 64-bit software. Everything has been rewritten in 64-bit. And what does that really mean? 64-bit, 64-bit. What that means is that, number one, ArcGIS Pro can address much more of your available RAM, and it can communicate with the CPU much faster than a 32-bit processing operating system or piece of software could ever communicate. We're not done at 64-bit, and the next one down the line is 128. I already have started seeing some 128-bit stuff floating around, a lot of discussion about that. So in the future, we will be seeing that. And of course, 64-bit actually also allows for better security on these systems. And in today's world, as you all know, that is quite important as well. ArcGIS Pro has its own set of tools. They are similar to and very familiar probably to you if you are a Arc Map or Arc Catalog user, but understand that they have been rewritten for ArcGIS Pro. It's not just that Esri took the code or took the little module from Arc Map and and rebranded it as ArcGIS Pro. No, they rewrote the entire thing to get it to work in and to compile in 64-bit. However, I will tell you this, the equations behind the scenes, way down in there, they're identical. Okay, they're identical equations. So if you have calculated slope, let's say, on a Lidar bare earth layer in ArcMap, and then you have a new project and you need to calculate slope for another bare earth layer, but this time using ArcGIS Pro, feel confident and feel assured that the slope process is identical in Pro versus ArcMap. I've got lots of benchmark testing and quantitative analysis to prove that if you need such a thing. But just understand that that is what's happening behind the scenes. The tools have been rewritten, similar and familiar, but they're actually processing the same way, just faster. ArcMap user, well, the worst thing that you can do is say, this isn't how it works in ArcMap. I hate this ArcGIS Pro, right? That's not good. That won't get you very far. Okay, go back to your software independent fundamentals, okay? We're talking about overlay processes, we're talking about spatial analysis concepts, the understanding of points, lines, and polygons and raster pixels. With that understanding in mind, you'll do just fine with ArcGIS Pro. But trying to say this square peg doesn't fit well in this round hole, well, they're just two different shapes, okay? They're different things. And what we need to do, if I could do it, you know that Men in Black movie? If I could take out one of those little pens and say, look here, and I flash that light in your eye, and you completely forget about ArcMap and ArcCatalog, that might be good for some people, right? You remember all the software independent fundamentals, but you forget how to do everything in ArcMap and ArcCatalog. Now you just learn Pro, that might work out really, really well. But of course, that's fiction, right? That's Hollywood. But we can do it, okay? We can do it. ArcGIS Pro, it is project-centric. It is designed for you to create an ArcGIS Pro project based on an actual project that you need to work on. So what we don't want to do is create an ArcGIS project for my new roads layer. Well, no, it's got to be bigger than that. It's not just roads that we're working on. You might have to, you know, assess the recovery of a fire, right? You may need to look at I don't know, a bunch of them. You may need to look at the structure of the forests in the Caribou-Targhee National Forest, right? Understory in the Caribou-Targhee. Okay, that's a project. That's a heck of a project, right? So that's what ArcGIS Pro is set up to work on. And think of it that way as you are creating new projects. It's also very cloud integrated. And the cloud that it integrates with is Esri's ArcGIS Online, okay? So that's some of the things we need to kind of get used to, as well as it has a Microsoft Office interface. So if you are accustomed to using Word, Microsoft Word, Microsoft Excel, then you're going to say, wow, this is so similar, ArcGIS Pro. Of course, I'm assuming that a lot of you haven't done much with Pro yet, and those of you who've done a lot with it, you're like, yeah, I know all this. To help you get through this exercise and this workshop as smoothly as possible, also understand that ArcGIS Pro is very context sensitive and context aware. So when we, the exercise might be saying, click the appearance ribbon, and you look up at the menu and the ribbon, you know, like right up here, you're looking up at the menu and the ribbon, and you do not see anything that says appearance, right? So what's wrong? Something's wrong with my program. Something's wrong. Okay, what's probably wrong is you do not have the correct item selected or highlighted in your contents pane. And the contents pane, hopefully you can see this on this slide. We'll have a little better example in the next slide. This is the contents pane. It always docks on the left side of your screen. The catalog pane always docks, at least by default, on the right side of your screen. We use those two tremendously. So if you don't have the correct item selected in the contents pane, ArcMap people used to be called the table of contents, then you won't see the appearance menu or the appearance ribbon, okay, or the raster data ribbon or whatever like that. So if the exercise is telling you to do such a thing and you don't see it, first thing you need to do, what do I have clicked on or selected in my contents pane? You make that change and then all of a sudden, oh, there it is. That's just how it is. Now you might say, boy, that wasn't very smart of Esri. Why didn't they just put everything out there on the menu, right? Make everything available. I'll tell you why. Because they'd have to have a scroll bar about over here. There's so many tools and capabilities and menus and submenus in ArcGIS Pro that it would actually overwhelm you. So that would be a bad approach. I think they did a good thing by making it context sensitive, context aware. Now all we need to do is kind of get used to that, right? We need to drink the Kool-Aid, as some people say. But yeah, we'll just get used to it. And if you see that problem, this menu is not appearing, he's talking about this menu, just change, look carefully at what you have selected in the contents. There's some new jargon, of course. There's panes, P-A-N-E-S, panes. Everything's called a pane. Contents pane, catalog pane. Oh my goodness. Okay, we'll get used to that. Geoprocessing tasks. We'll end up running various different geoprocessing tools, and they then are tasks, right? They are tasks that are running or we have completed. There's some jargon literally there. The graphical user interface, there we have on the left side the contents pane. The right side is our catalog pane. There's a geoprocessing pane, and once we open up the geoprocessing pane, it will dock right over here by the catalog pane. And when we have both the catalog, when we're using both the catalog pane and the geoprocessing pane, we'll end up seeing tabs down here. We're also going to be making use of a task. It's a suite of tools that have been put together to help you step through LiDAR processing. Okay, so I got this from Esri, from their leveraging LiDAR tools, and you will be loading this task into your project, and then that task will dock itself on the left side of the screen, left side of the window, the graphical user interface. And so then you'll have the contents pane and a tab down here, which will be the tasks pane, and you'll be toggling back and forth between each of those. And that should be pretty easy to figure out once you start working with it. It is licensed, ArcGIS Pro is licensed by named user in ArcGIS Online for your organization. And since you are participating in the workshop here at Idaho State University, I'm going to have all of you log in for using a username and password that I will provide from our organization here at ISU. A couple reasons for doing that is, number one, I know that the licensing permissions, 3D analyst, spatial analyst, all this good stuff like this, are sufficient for you to complete the entire exercise, because you'll be using what's called ArcGIS Pro Advanced. And secondly, if you burn any credits, you'll be burning credits here at ISU, which makes sense. You are students of this workshop, so it's not a problem. And instead of burning credits at your own organization, okay? And by the way, credits are effectively dollars, okay? So I'll have you burn credits. If we do burn any, we'll burn them here on this side instead of on your own organizations. And I will give you your login information in just a little bit. Okay, are there any questions? I see a couple things in the chat.